The primary classification of Earth's climates is known as the Koppen-Geiger climate classification system. If you've ever taken a geography class and learned about climate zones, chances are you were studying this system. It serves as the foundation for understanding global climate patterns and their profound influence on ecosystems, agriculture, and human life. Why is it important to learn about the Koppen-Geiger system? First, it offers a systematic way to categorize the world's diverse climates based on temperature and precipitation, making complex environmental data accessible and comprehensible. This system also provides insights into why specific regions, such as the Amazon rainforest, have lush vegetation, while others, like the Sahara Desert, remain barren. Moreover, understanding the Koppen-Geiger classification is crucial in the context of climate change. As global temperatures rise and weather patterns shift, this system helps us analyze and predict changes in climate zones, offering a valuable tool for scientists, educators, and policymakers alike. This video will guide you through the secrets of mastering the Koppen-Geiger system, helping you ace any geography test while uncovering the fascinating connections between diverse climates and the civilizations they shape. The Koppen-Geiger climate classification system was first introduced by German climatologist Vladimir Koppen in 1900. Koppen sought to link climate patterns with vegetation types, classifying climates based on temperature and precipitation. He established 5 main climate categories, and each is identified by a shorthand capital letter. Tropical, A, found near the equator, characterized by consistently hot temperatures and significant rainfall throughout the year or during specific seasons. Dry, B, encompasses regions that receive very little precipitation, such as deserts and semi-arid areas, typically found in subtropical or continental zones. Temperate, C, features moderate temperatures with mild winters and warm summers, typically located at mid-latitudes near coastlines. Continental, D, describes areas with large temperature variations, found in inland regions of continents, where winters are typically cold or very cold. Polar, E, includes regions of cold temperatures year-round, typically located near the poles or at high altitudes. By the 1930s, Helmut H.L. Sonander, a Swedish climatologist, added a further expansion to the system by introducing the Highland H category. This new classification recognized the unique climate conditions of mountainous regions, where high altitudes create different climatic zones compared to surrounding lowlands. Though the 6 categories gained widespread adoption, climatologists refined the system further by defining specific latitude ranges for each climate category. These boundaries were added in the mid-20th century to better understand global climate distribution. For example, tropical climates A are typically found between 0 degrees, the equator, and 23.5 degrees, the Tropic of Cancer and Tropic of Capricorn latitude. Dry climates B are concentrated between 20 degrees and 30 degrees latitude. Temperate climates C occur between 30 degrees and 60 degrees latitude. Continental climates D are found between 40 degrees and 70 degrees latitude, and polar climates E are located beyond 66.5 degrees latitude. The Arctic and Antarctic circles. These ranges are based on climatic patterns influenced by global atmospheric circulation cells, such as the Hadley, Ferrel, and polar cells. Now that we have the 6 major climate categories, they still don't fully align with the climate codes we commonly use today. How did these detailed codes come about, and how should we understand them? To answer that, we need to introduce another key contributor to the system, Rudolf Geiger. In the mid-20th century, as a German climatologist and collaborator of Koppen, Rudolf Geiger significantly advanced the system, and many of the crucial subdivisions we recognize today were introduced through his work. So, you'll often see the system referred to by 2 names, reflecting the contributions of both Koppen and Geiger. Now, let's take a look at some of the key climate subdivisions and what the codes mean. First, let's explore the 3 main tropical climate types, AF, AM, and AW. But what does the second letter actually mean? In fact, the second letters in these codes, F, W, and M, originate from German terms and describe specific rainfall patterns. F comes from few hit, meaning wet or moist. and indicates a climate with no dry season, like tropical rainforests. M stands for monsoon, the German word for monsoon, describing climates influenced by monsoonal wind, with a pronounced wet season and a shorter dry season. W is short for wintertrocken, meaning dry in winter, representing climates with a dry season in winter, as seen in some tropical savannas. While both W and M refer to climates with wet and dry periods, their patterns differ significantly. W climates experience a clear dry season in winter and moderate annual rainfall, while M climates are dominated by a strong monsoonal system, with much higher rainfall during the wet season and only a brief dry spell. Now, with the understanding of rainfall patterns codes, let's now explore the characteristics of the three main tropical climate types. Tropical rainforest is driven by the Intertropical Convergence Zone, ITCZ, where warm, moist air converges, creating consistent convectional rainfall. Temperatures are high and stable year-round, averaging 25 degrees Celsius to 28 degrees Celsius. Rainfall exceeds 2,000 millimeters annually, falling evenly throughout the year. This climate supports lush, dense vegetation, including towering evergreens and layered canopies that house incredible biodiversity. Agriculturally, the off-climate is ideal for crops like cocoa, bananas, cassava, a vital staple, and rubber. Geographically, these regions are found in the Amazon Basin, Congo Basin, and Southeast Asia. Historically, these fertile areas supported advanced civilizations, such as the Maya and various African tribal societies, and continue to sustain communities with their abundant natural resources. AM tropical monsoon climates are driven by monsoonal wings, caused by seasonal shifts in atmospheric pressure between land and ocean. Temperatures remain warm year-round, ranging from 25 degrees Celsius to 30 degrees Celsius, with slight seasonal variations. Rainfall ranges from 1,000 to 1,800 millimeters annually, concentrated during a pronounced rainy season that accounts for most of the precipitation. Vegetation here resembles that of rainforests, but is less dense, often including deciduous trees that shed leaves during the short dry season. This climate supports rice paddies during the wet season and crops like tea, sugarcane, and spices. Found in South Asia, for example, India, Bangladesh, parts of West Africa, and the Caribbean, these regions are home to thriving agricultural and cultural hubs, such as the Khmer Empire, which flourished from the 9th to the 5th–10th century. Tropical savanna climates result from the shifting ITCZ in subtropical high-pressure systems, creating distinct wet and dry seasons. Temperatures are consistently high, averaging 25 degrees Celsius to 30 degrees Celsius, with minor cooling during the dry season. Rainfall is limited to 500 to 1,000 millimeters annually, concentrated in a short wet season, while the long dry season dominates the year. Vegetation consists mainly of grasslands with scattered drought-resistant trees, supporting grazing animals and iconic ecosystems like the African Serengeti. Agricultural activity includes livestock grazing and cultivation of resilient crops such as millet, sorghum, and maize. These regions are found in sub-Saharan Africa, northern Australia, and parts of Brazil. The climate has shaped human activities for millennia, from African tribal societies to modern cattle-rearing communities. Now that we've explored the rainfall patterns of tropical climates, let's move on to discussing the temperature subdivisions and how they apply to the B arid climate category, specifically focusing on the W and S for dryness and H and K for temperature. W stands for west, the German word for desert, representing hot deserts or cold deserts. This climate has extremely low annual rainfall, often under 250 millimeters. S stands for steppe, indicating semi-arid areas with more rainfall than deserts, but still limited compared to other climates. Steppe climates can support grasslands and shrubs, as seen in BSK cold steppe or BSH hot steppe climates. The third letter in the B climate classifications, H and K, further refines the temperature characteristics. H comes from the German word heiß, meaning hot, and describes regions with extremely high temperatures, often with summer highs above 30 degrees Celsius. Finally, K comes from the German word kalt, meaning cold, and applies to regions that experience cooler winters often with an average temperature of the coldest month below 0 degrees Celsius. Now, let's delve into the temperature and precipitation characteristics of the dry climate types. The BWH climate is primarily influenced by subtropical high-pressure systems, which create dry, hot conditions with minimal cloud cover. Daytime temperatures often soar between 30 degrees Celsius and 40 degrees Celsius, while nighttime temperatures remain warm, rarely falling below 20 degrees Celsius. Annual precipitation is extremely low, usually under 250 millimeters, with sporadic, intense rainfall events. Vegetation in these areas is sparse, consisting mainly of cacti, succulents, and drought-resistant shrubs. Agriculture here is highly dependent on oases, where crops like date palms can thrive, or livestock such as camels and goats are raised. Key locations that exhibit this climate include the Sahara Desert, the Arabian Peninsula, and parts of Mexico. Historically, civilizations such as ancient Egypt and Mesopotamia flourished in these regions, utilizing irrigation systems along rivers to support agriculture and thriving cultures. The BWK climate is often found in high-altitude or rain shadow areas, influenced by cold air masses that bring significant temperature fluctuations. Summers can be quite warm, reaching up to 35 degrees Celsius, but winters are cold, often dipping below freezing, with temperatures ranging from -5 degrees Celsius to 15 degrees Celsius. Precipitation remains scarce, typically under 250 millimeters annually, but it is more evenly spread throughout the year compared to the BWH climate. Vegetation is also sparse, with grasses and shrubs adapted to cold, dry conditions. Agriculture in BWK climates is limited and typically confined to areas with access to water, such as oases or river valleys. In these regions, cold-resistant crops like barley and wheat are cultivated, especially in areas where irrigation or seasonal rainfall supports farming. Additionally, pastoral activities, including sheep and goat herding, are the primary form of agriculture in these areas, as these animals are well suited to the harsh, dry conditions. This climate is typical in areas such as the Great Basin of the United States, the Mongolian Plateau, and the Gobi Desert. The region has been historically home to empires such as the Mongol Empire and various nomadic cultures, who relied on herding and extensive trade networks. The BSK climate occurs in regions at the edges of deserts or near mountain ranges, where cold, dry air masses dominate. Summers are warm, with temperatures ranging from 20 degrees Celsius to 30 degrees Celsius, while winters are cold, with temperatures often dipping below 0 degrees Celsius. Annual precipitation is slightly higher than that of the BWK climate, ranging from 250 millimeters to 500 millimeters, and is mostly concentrated in the summer months. Vegetation is mainly steppe grasslands, with sparse shrubs and small trees scattered across the landscape. Agriculture in these areas is limited, with the cultivation of cold-tolerant crops like barley and wheat occurring primarily in more favorable regions, while livestock herding remains the dominant agricultural activity. Additionally, sectors like mining, particularly in Central Asia and parts of the Great Plains, and industrial activities, including oil and gas extraction, contribute significantly to the local economy. Regions of this climate type include the Great Plains of North America, parts of Central Asia. The steppe climate has shaped the development of civilizations like the Scythians and various nomadic cultures, who relied on pastoralism and extensive trade routes. The BSH climate is driven by the interaction of subtropical high-pressure systems and seasonal monsoonal wings, which create distinct wet and dry seasons. Summer temperatures can exceed 30 degrees Celsius, while winter temperatures remain mild, typically between 10 degrees Celsius and 20 degrees Celsius. Precipitation ranges from 250 millimeters to 500 millimeters annually, with the majority of rainfall occurring during the summer monsoon season. Vegetation consists of grasslands mixed with scattered shrubs and trees, supporting wildlife and livestock. Agriculture in this climate includes drought-resistant crops such as sorghum, millet, and cotton, along with extensive pastoral activities. The BSH climate is found in regions such as southern Africa, the Saharan Fringe, and northern Australia. Civilizations in these areas, such as various African empires, developed agricultural techniques and trade networks that have lasted through the centuries. Let's now move on to explore the temperature subdivisions that further define the C and D climate types. But what does the letter A, B, or C mean in these codes? These subdivisions are used only in C temperate climates and D continental climates to indicate variations in temperature within these broader climate types. A stands for hot summers, meaning that the warmest month of the year has an average temperature above 22 degrees Celsius. B indicates warm summers, where the warmest month has an average temperature between 10 degrees Celsius and 22 degrees Celsius, and at least 4 months have an average temperature of is greater than or equal to 10 degrees Celsius. C refers to cool summers, where the average temperature of the hottest month is below 22 degrees Celsius, and only 1 to 3 months per year have an average temperature of is greater than or equal to 10 degrees Celsius. D stands for cold winters, meaning that the coldest month of the year has an average temperature below -3 degrees Celsius, 27 degrees Fahrenheit. Also, you may notice that compared to type A climates, the second letter in CD climates includes a variant with an S, which signifies a summer dry or dry summer climate. S stands for Sommertrocken, which is German for dry in summer. This summer dry pattern is relatively rare and typically found in regions such as the Mediterranean, where hot, dry summers are contrasted with mild, wetter winters. Next, we will discuss each of the C and D climate types. However, since there are many subdivisions, we will focus only on the most common climates. The CFA climate, or humid subtropical climate, is characterized by hot, humid summers and mild winters. It is primarily driven by the seasonal shifts in atmospheric pressure systems, including the subtropical high-pressure systems during summer and mid-latitude cyclones during winter. The warmest month experiences temperatures above 22 degrees Celsius, while winter temperatures generally range between 0 degrees Celsius and 18 degrees Celsius. Precipitation is abundant and fairly evenly distributed throughout the year, with annual totals ranging from 1,000 millimeters to 2,000 millimeters, often accompanied by frequent thunderstorms. In terms of vegetation, the CFA climate is home to a variety of ecosystems, ranging from broadleaf evergreen forests to swamps and grasslands. These ecosystems thrive in the humid environment created by the regular rainfall. However, much of the natural vegetation has been replaced by agricultural land, with crops such as rice, cotton, tobacco, and a variety of fruits like citrus, peaches, and grapes being cultivated. The CFA climate is found in some of the most densely populated regions in the world, including the southeastern United States, southern China, southern Japan, parts of Argentina, such as the Pampas region, and parts of Australia, including the southeastern coastal areas. These regions are not only important for agriculture, but have also historically supported great civilizations and many large, modern cities. In the United States, the southern plantations have long depended on the climate to grow cash crops such as cotton, tobacco, and rice. China's southern regions are well known for rice cultivation, which has been central to the culture and economy for centuries. Similarly, Japan has developed a sophisticated agricultural system in this climate, focusing on rice and fruit production. The CW climate, classified as subtropical monsoon, is primarily found in the eastern parts of continents, near the tropics, where it experiences a combination of subtropical and monsoonal influences. The climate is characterized by distinct seasonal shifts, with a long hot, wet summer and a cool, dry winter. During the summer, the wet monsoon season brings heavy rains, often exceeding 1,000 millimeters annually, driven by the seasonal shift in atmospheric pressure and wind patterns. The winter season is dry and cooler, influenced by subtropical high-pressure systems, which suppress rainfall. The natural vegetation in CW climates is a mix of tropical forests and savannas, with lush, dense vegetation during the wet season, while grasslands and deciduous trees may dominate in the dry winter months. These climates support a wide variety of plant and animal life due to the combination of ample rainfall in the summer and milder, cooler winters. Agriculture is abundant, especially during the wet season, with crops such as rice, tea, sugarcane, and spices thriving in these regions. Rice cultivation, in particular, is a key economic activity, particularly in South and Southeast Asia. These regions are situated in countries like China, India, Bangladesh, and parts of Brazil. Historically, regions with a subtropical monsoon climate have been home to significant civilizations, such as the Indus Valley Civilization and later the Mughal Empire in India. Today, these areas continue to support dense populations and robust economies, with agriculture as a major contributor to local and national economies. The siesta climate is found in regions that are located at the western edge of continents in mid-latitudes, typically between 30 and 40 latitude. These areas experience hot, dry summers and mild, wet winters, thanks to the influence of oceanic westerly winds that bring rainfall during the winter months. Summer temperatures are typically high due to the subtropical high-pressure systems, while winter temperatures are moderate and usually range from 5 degrees Celsius to 18 degrees Celsius. Summer in CSA climates is characterized by long dry periods, with rainfall being scarce and usually not exceeding 50 millimeters per month. The dry season results in vegetation that is adapted to drought conditions, often taking the form of shrubs and evergreen trees that can survive without much water. Winter months, however, bring more consistent rainfall, often exceeding 400 millimeters annually, which supports growth of deciduous plants and grasses during the cooler months. The natural vegetation in CSA climates is typically sclerophyllous hardleaf vegetation, which includes shrubs, drought-resistant trees, and low-lying plants. Forests of oak and pine are common in more temperate regions. Agriculturally, the CSA climate is renowned for producing a variety of crops, especially those that thrive under dry summer conditions. Olives, grapes, citrus fruits, and wheat are staples of the Mediterranean diet and are key crops in these regions. The dry, hot summers and mild, wet winters are ideal for vineyards and orchards. The climate also supports livestock farming, especially in regions like southern Spain, southern Italy, and parts of California. Key locations for this climate include Southern California, USA, the Mediterranean basin, southern Spain, Italy, Greece, Turkey. These regions are important for agriculture and also serve as major tourist destinations due to their pleasant, sunny weather and fertile agricultural landscapes. Historically, the CSA climate has supported major civilizations. The ancient Greek, Roman, and Phoenician civilizations flourished in Mediterranean regions, where agriculture, trade, and culture thrived. Today, the Mediterranean basin remains a region with rich cultural heritage, as well as a major agricultural center, especially in the production of wine, olives, and citrus fruits. The CSB climate, found on the western coast of continents like its CSA counterpart, differs in its cooler summers. While CSA regions experience hot, dry summers, CSB summers are warm, around 20 degrees Celsius to 25 degrees Celsius, making them more temperate and comfortable. Winters in CSB regions are cooler than CSA, with temperatures ranging from 5 degrees Celsius to 10 degrees Celsius. The annual precipitation ranges from 600 millimeters to 1,000 millimeters. Rainfall in CSB regions is heavier than in CSA and is concentrated in the winter months, supporting a more lush vegetation of coniferous forests, for example, redwoods and sequoias and deciduous trees. Agriculturally, CSB regions support a mix of Mediterranean staples, grapes, olives, wheat, and cool season crops like apples, pears, and vegetables, as well as livestock grazing and timber production, benefiting from cooler summers and heavier winter rainfall. Key locations include parts of the Pacific Northwest, USA, southern Australia, and southern Europe, notably northern Spain, Portugal, and Italy. The CFB climate, often referred to as oceanic, is characterized by mild temperatures and consistent rainfall throughout the year. Found primarily on the western coasts of continents in temperate zones, it is also present in subtropical highland areas where altitude moderates the climate. CFB climates are shaped by oceanic air masses that regulate temperatures and supply moisture year-round. In subtropical highland areas, elevation enhances the cooling effect and contributes to distinct climatic characteristics. Westerly winds play a crucial role in delivering steady rainfall, ensuring the region's lush greenery and agricultural potential. Temperatures in CFB regions are mild and stable, with summers ranging from 15 degrees Celsius to 22 degrees Celsius and winters staying relatively cool at 2 degrees Celsius to 10 degrees Celsius. These areas experience minimal seasonal extremes due to the moderating influence of oceans or altitude. Annual rainfall typically ranges from 800 to 2,000 millimeters, distributed evenly throughout the year. This consistent precipitation supports abundant vegetation and provides a reliable water supply for agriculture and local communities. The lush landscapes of CFB climates feature temperate forests with a mix of deciduous species like oak, beech, and birch, and evergreen conifers. In subtropical highland variations, vegetation often transitions to montane forests and grasslands, adding ecological diversity to the region. The fertile soils and steady rainfall make CFB climates highly productive for agriculture. Staple crops such as wheat, barley, and rye thrive here, alongside fruits like apples and pears. Dairy farming is particularly significant, benefiting from the rich pastures of these regions. Key locations for this climate include Western Europe, for example, the UK and northern France, New Zealand, parts of southeastern Australia, the Pacific Northwest of North America, for example, Seattle and Vancouver. Small upland regions close to the equator, like those in Colombia and Ecuador, enjoy a mild climate throughout the year, which can also be classified as CFB climates. Oceanic regions have historically supported dense populations and advanced civilizations, such as those in medieval Europe, due to their agricultural abundance and favorable living conditions. The CFC, subpolar oceanic climate, is found primarily in the high-latitude coastal regions, particularly on the western coasts of continents, such as Iceland and the Faroe Islands. These areas experience cool to cold temperatures year-round, with no month exceeding 10 degrees Celsius on average. CFC climates are characterized by long winters and short, cool summers, but they remain relatively stable due to the moderating influence of the ocean. Rainfall is fairly consistent throughout the year, often ranging from 800 millimeters to 1,500 millimeters annually. The precipitation is mainly driven by moist air from the oceans and is usually distributed evenly across all seasons, though winter may bring heavier snow. These regions can also be subject to strong winds from the oceans, adding to the cool and damp conditions. The natural vegetation in CFC climates is characterized by lush, green landscapes, which support various plant species, including deciduous trees and conifers such as spruce and pine. Agriculture in CFC climates is characterized by a short growing season and focuses on hardy crops like root vegetables and cold-resistant grains. High annual rainfall supports lush pastures for livestock, such as sheep and cattle. Farmers often use sustainable practices and may employ greenhouses to extend the growing season. Key locations for CFC climates include parts of the Faroe Islands, northern Norway, Scottish Highlands. They primarily rely on agriculture and fishing, with a focus on sustainable practices to adapt to their cool, moist climates. Subtropical highland climates, classified as CWB and CWC, are found in elevated regions of subtropical areas, where altitude plays a dominant role in shaping their unique characteristics. These regions often occur at high altitudes near the tropics, such as in the Andes and parts of the Himalayas. Summer monsoons and winter westerlies often bring rainfall, with CWB experiencing a milder, wetter summer compared to the cooler, drier summers of CWC. CWB summers are mild, ranging from 15 degrees Celsius to 22 degrees Celsius, while winters are cool but rarely harsh, with averages around 5 degrees Celsius minus 10 degrees Celsius. CWC, slightly cooler overall, with summer temperatures below 15 degrees Celsius and winter temperatures near freezing. Rainfall is concentrated in the summer months, ranging from 500 to 1,200 millimeters annually. CWB is wetter, while CWC tends to be drier and occurs at even higher altitudes. Vegetation includes grasslands, temperate forests, and shrubs, adapted to the cooler conditions. These regions also support cloud forests, which are unique to high-altitude climates with consistent moisture. Due to their moderate temperatures, these regions support diverse crops such as potatoes, barley, maize, and tea. Livestock grazing is also common in higher altitude areas. CWB, Central Andes, for example, Bolivia, Peru, Indi-Himalayan foothills, East African highlands. CWC, higher altitudes in the Andes and some Himalayan valleys. Historically, these climates supported advanced highland civilizations like the Inca in South America and various Himalayan kingdoms. Modern agricultural practices continue to thrive, particularly in the production of tea and staple crops. The DFB, humid continental climate is found primarily in the interior of large continents, especially in regions away from the coast, where the climate is significantly influenced by the continental environment. These areas experience distinct seasonal temperature variations, with hot summers and cold winters. The DFA classification refers to areas with hot summers, where the warmest month exceeds 22 degrees Celsius, while DFB refers to cooler summers, where the warmest month is below 28 degrees Celsius, but still experiences a significant temperature difference from winter. In both types of humid continental climates, precipitation is relatively evenly distributed throughout the year, although it tends to be higher in the summer months due to the influence of thunderstorms and frontal systems. Rainfall typically ranges from 500 millimeters to 1,000 millimeters annually. In the DFA region, summers tend to be wetter due to more frequent thunderstorms, while the DFB regions may have slightly more evenly spread rainfall across seasons. These regions are characterized by deciduous forests, with trees such as oak, birch, and maple, as well as coniferous forests in cooler areas. In the colder parts of DFB, mixed forests are more common, while DFA areas may have expansive grasslands or prairies. Agriculturally, DFB climates are ideal for crops like wheat, corn, oats, and soybeans, as well as certain fruits such as apples, cherries, and grapes. Livestock farming is also prominent, particularly cattle and sheep in the cooler areas. The temperate nature of these climates allows for the cultivation of a wide variety of crops during the warmer months. Key locations for the DFB climate include parts of the United States, such as the Midwest, much of Russia, and parts of Central Europe, including Poland, Hungary, and parts of Germany. These regions are often the economic and agricultural hubs of their respective countries. Historically, the humid continental climate has supported significant civilizations due to its fertile lands and ability to sustain diverse agriculture. In Russia, the fertile soil of the Black Earth region, including parts of Ukraine, has supported vast agricultural output, including wheat, barley, and sunflowers, which have been critical for both historical empires and modern industrial economies. In Europe, areas like Poland and Hungary have been historically known for grain cultivation, playing a key role in the development of agricultural economies that supported feudal systems and later industrialization. The DWB climate, also known as the continental monsoon climate, is characterized by significant seasonal precipitation variation, mostly occurring in the summer due to the monsoon. Temperature: winters are cold, often dropping below freezing, ranging from -15 degrees Celsius to -25 degrees Celsius, while summers are hot, with average temperatures between 25 degrees Celsius and 30 degrees Celsius. The seasonal temperature difference is quite dramatic, making the DWB climate one of the most extreme in terms of temperature variation. Rainfall is concentrated in the summer months due to the monsoon winds. Total annual rainfall typically ranges between 400 millimeters to 800 millimeters, with most of the precipitation falling from June to August. Winters are dry, with little to no rainfall. The natural vegetation in DWB regions varies depending on the amount of rainfall, with grasslands and steppe dominating the drier areas, and deciduous forests found in more humid zones. The summer rains support the cultivation of crops such as wheat, barley, maize, and rice in areas with more moisture. Livestock grazing is common in the grassland regions, while wetter areas can also support rice cultivation, especially in the lower-lying river valleys. Key locations: Asia. The DWB climate is found in the northeastern and northern China. It also extends to Korea and Mongolia. Other regions: smaller parts of Siberia and the Tibetan Plateau also experience this climate. Historically, DWB regions have supported agricultural societies, particularly in the fertile river valleys where summer rains allow for the cultivation of vital crops such as wheat and barley. In China, for example, the DWB climate has shaped the agricultural foundations of major civilizations, including the Han and Tang dynasties, which thrived due to the fertile lands supported by summer monsoon rains. The DSB climate is characterized by hot, dry summers and cold winters, primarily found in the interior of continents where the moderating influence of oceans is minimal. These regions experience extreme seasonal temperature fluctuations, with summer temperatures ranging from 25 degrees Celsius to 35 degrees Celsius, while winters can drop as low as -10 degrees Celsius to -30 degrees Celsius. Precipitation in these areas is generally low, totaling 300 to 600 millimeters annually, with the majority falling during the winter months, leaving summers notably dry. Vegetation in the DSB climates is adapted to the harsh conditions, with grasslands, drought-resistant shrubs, and steppe covering the landscape. In milder areas, temperate forests with species like oaks and junipers can be found. Agriculture is focused on crops that can withstand both dry conditions in summer and cold winters, including wheat, barley, rye, and corn. These regions also support livestock farming, particularly in areas where pastures are available. Key locations include Central Asia, for example, Kyrgyzstan, Afghanistan, Tajikistan, the Rocky Mountains, and the Anatolia Plateau. Historically, these areas have supported ancient civilizations such as the Scythians in Central Asia and the Hittite Empire in Anatolia, as well as the trade networks that connected these regions to other parts of the ancient world. The subarctic climate, also known as the boreal climate, is characterized by extremely cold winters and relatively mild summers. It is primarily found in high-latitude regions of the northern hemisphere, close to the Arctic Circle, where seasonal temperature extremes are a defining feature. Subarctic winters are long and bitterly cold, with temperatures often dropping to -30 degrees Celsius to -40 degrees Celsius in the DFD climate and -25 degrees Celsius to -40 degrees Celsius in the DFC climate. These regions experience long periods of freezing temperatures, and the cold is a dominant feature of life throughout the year. Summers in the DFC regions are relatively mild, with temperatures ranging from 10 degrees Celsius to 15 degrees Celsius, whereas in the DFD areas, summer temperatures are slightly cooler, typically between 5 degrees Celsius to 10 degrees Celsius. Precipitation is typically low in both climates, ranging from 300 to 600 millimeters per year. Most of the precipitation occurs during the summer months, though snowfall in the winter contributes significantly to the overall annual rainfall. The natural vegetation of the DFC and DFD regions is dominated by boreal forest taiga, which consists of coniferous trees like spruce, pine, and fir. In the colder DFD regions, the vegetation is sparse, with areas of tundra and open woodlands. The extreme winter temperatures limit the growing season to a few short months, making agriculture a challenge. In the DFC climate, some hardy crops such as potatoes, barley, and rye can be cultivated, but yields are generally low. In the DFD climate, agriculture is almost impossible, except for a few regions where specialized farming techniques like greenhouses are used. DFC regions are found in the northern Canada, such as the Yukon and Northwest Territories, Alaska, Scandinavia, Siberia, notably around Irkutsk, and the Kamchatka Peninsula. DFD areas are even colder, mostly located in northern Siberia. Historically, The harsh conditions of the subarctic have limited human settlement, though indigenous groups such as the Sami in Scandinavia and the Ukagurs in Siberia have adapted to life in these extreme environments. Today, both DFC and DFD regions are sparsely populated, with mining and natural resource extraction being the main economic activities. The DWC and DWD climates are found in regions influenced by monsoonal wings, located in the subarctic and high-altitude regions. These climates are very similar to DFC and DFD, but they are distinguished by stronger monsoon influences during the summer. Both climates have a monsoonal influence that brings more summer rainfall compared to DFC and DFD. The summer rains can be significant, often 400 millimeters to 600 millimeters per year, concentrated in the monsoon season, with winters remaining dry. Similar to DFC and DFD, boreal forests dominate, but the increased summer rainfall may allow for more grasses and shrubs to grow. In the colder DW'd zones, tundra vegetation remains prevalent. In DWC areas, agriculture is more viable than in DFC due to the slightly longer growing season and additional summer rainfall. Hardy crops such as barley and oats can be grown, along with livestock grazing. In DWD regions, agriculture is almost non-existent, with only limited subsistence farming and nomadic herding practiced. These climates are found in parts of Mongolia and certain areas of Siberia, such as Transbaikalia. Finally, let's discuss the polar climates, including tundra and ice cap. The letter T refers to tundra. The letter F is generally understood to represent the term frost. The tundra climate is characterized by extremely cold temperatures year-round, with short, cool summers and long, harsh winters. The average temperature during the warmest month does not exceed 10 degrees Celsius, and the coldest months are well below freezing. Precipitation is low, typically less than 250 millimeters annually, and it usually falls as snow. The vegetation is sparse, consisting mainly of mosses, lichens, and small shrubs, due to the short growing season and permafrost that restricts deep root growth. The tundra climate is found in high-latitude regions near the Arctic and Antarctic circles, including parts of Alaska, Canada's Arctic archipelago, Greenland, and the northern Siberian coast. The vegetation is adapted to extreme cold and short summers, with much of the land remaining covered by snow and ice for much of the year. Agriculture is non-existent, but the tundra ecosystems support various migratory species during the short summer months. The ice cap climate is one of the coldest and driest on Earth. Temperatures remain below freezing throughout the year, with the warmest month having an average temperature of 0 degrees Celsius or lower. Precipitation is very low, usually in the form of snow, and there is very little seasonal variation in temperature. The ice cap regions are covered by vast ice sheets and glaciers, and vegetation is entirely absent, making the landscape stark and barren. This climate is found primarily in polar regions, including the interior of Greenland, Antarctica, and high-altitude areas of the Andes or Himalayas. Due to the extreme cold and lack of sunlight for most of the year, these regions are devoid of vegetation and sustain very few species, mostly adapted to the harsh cold environment. We've now covered all the basic climate types, from the hot tropical rainforest AF to the icy ice cap EF. I hope this helps you better understand the characteristics and distribution of Earth's diverse climate zones. If you enjoyed this video and found it helpful, don't forget to like, subscribe, and turn on the notification bell so you won't miss any more exciting content about climate and geography. If you have any questions or want to learn about other climate types, feel free to leave a comment below. I'll respond as soon as I can. Thanks for watching, stay curious, and see you next time.